says we are given this, and then we need to solve all those questions, right? It says, without using a calculator, determine each of the following in terms of P. So it must be in terms of P. So the first thing that you do in this case, you need to work out your diagram. Now your diagram, you need to draw a right angle triangle. So allow me to draw one here. Okay, there's my right angle triangle. Okay, and then I put in the values. So this, I'll choose it to be 36 degrees and then 90. And you know that 90 degrees minus 36, you get 54 degrees. So this is going to be 54 degrees. And then because it's sine we know, sine theta, we know that is opposite over hypotenuse. So therefore, in this case, this is going to be my opposite. Standing from this angle, this is my opposite. And my opposite is going to be 1 minus p squared, like that, square root, right? And then obviously, with this one, this is the same as the opposite is 1 minus p squared over, because this is not a fraction, it doesn't have a, it is not in a form of a fraction form, rather. It means that the denominator here is 1. The denominator is 1, so you can just put 1 here. So now, this 1 corresponds with my hypotenuse, so it simply means that my hypotenuse is actually 1. So I'll put a 1 there. Now I need to find this side. Remember, when you the Pythagoras theorem, right? It says r squared is equal to x squared plus y squared. I'm looking for my x squared. It's going to be r squared minus y squared. R squared being your hypotenuse, it's going to be 1 squared minus x squared is square root of 1 minus p squared. And then this is the same as 1 minus 1 plus p squared. Therefore, this is equal to square root of, we know that 1 minus 1 is 0, so we're left with p squared, therefore x is equal to p. Now I'll take this x and put it there, this value of p. So this side is equal to p. Now we can start solving the equation. 5.3.1, it says tan of 36 degrees. Tan is the same as opposite over adjacent. And then in this case, my opposite is 1 minus p squared, all under a square root sign. Divide by. My adjacent is going to be p, so I'll divide by p. And then this part is done. Moving on to 5.3.2. So we have cos 108. Cos 108 can be written as cos 2 times 54 degrees. Because 54 times 2 is 108. And then we say, okay, this is a double identity. You can take this 54 as x. So this can be taken as, if you allow me, this can be taken as cos 2 times x. And we spoke about double identities here. Cos 2 times x. So it can be written as 1 minus 2 cos squared x. Shucks, sorry guys, this is supposed to be sine squared. This is supposed to be sine squared, not cos squared. Sine squared x, apologies on that. Yes, so I can choose to make it look like this or like that one. So I'm going to choose to make it look like this. So I'm going to swap this, but where there's x, I put 54. So this is the same as 1 minus 2 sine squared 2 times 54 degrees, not x. Excuse me, 2 times 54 degrees, not 2 times. Sine 2 sine squared 54 degrees. I don't know why I keep making mistakes. Right, but I hope I don't lose you. And then we have 1 minus 2 sine squared. So this one, I'm going to open the bracket. Sine 54, from this angle, sine 54 is opposite over hypotenuse. So it's p over 1. So I'm going to have p over 1 squared. Everything must be squared. Same as 1 minus 2p squared as the answer. And then now this brings us to the end of the question. And thank you once again for watching this question. And please keep watching more videos that we post, because the more you watch, the more we get motivation to keep making videos for people like you guys. And then please make sure you subscribe, just to support this channel, the growth of this channel. Enjoy your day, and I hope this question addressed some of the challenges that you had. Goodbye.